വെൽക്കം ടു കോമ്പറ്റേറ്റീവ് ക്രാക്കർ. എല്ലാവർക്കും സ്വാഗതം. നമുക്കറിയാം നമ്മൾ നെറ്റ് പരീക്ഷയോട് അടുത്തിരിക്കുകയാണ്, ഫിസിക്സിൻ്റെ നെറ്റ് പരീക്ഷയോട് അടുത്തിരിക്കുകയാണ്. അപ്പോൾ ഇനി വേറൊരു സാഹചര്യങ്ങളൊന്നും ഉണ്ടായില്ലെങ്കിൽ തീർച്ചയായും അവർ നിശ്ചയിച്ചിരിക്കുന്ന 25, 26, 27 തീയതികളിലായിട്ട് നമ്മുടെ നെറ്റ് പരീക്ഷ നടക്കും. അപ്പോൾ എല്ലാവർക്കും ആദ്യമേ തന്നെ കോമ്പറ്റേറ്റീവ് ക്രാക്കറിൻ്റെ ഭാഗത്തു നിന്നും എല്ലാ വിജയാശംസകളും നേരുന്നു. CSIR നെറ്റ് ഫിസിക്സ് പരീക്ഷ എഴുതുന്ന ഈ വീഡിയോ കാണുന്ന എല്ലാവർക്കും ആത്മാർത്ഥമായ വിജയാശംസകൾ നേരുന്നു. നന്നായിട്ട് പോയി പരീക്ഷ എഴുതാൻ പറ്റട്ടെ, ടെൻഷനൊന്നും കൂടാതെ നന്നായിട്ട് പോയി പരീക്ഷ എഴുതാൻ പറ്റട്ടെ. അപ്പോൾ നമ്മൾ ഇന്ന് ഈ വീഡിയോയിലൂടെ നിങ്ങൾക്ക് കുറച്ച് ആത്മവിശ്വാസം പകരാൻ ഉദ്ദേശിക്കുന്ന കുറച്ച് കാര്യങ്ങൾ പറയാനും കുറച്ച് ചോദ്യങ്ങൾ ഡിസ്കസ് ചെയ്യാനും ഒക്കെ ആയിട്ടാണ് നമ്മൾ ഇന്ന് ഈ വീഡിയോയിലൂടെ വന്നിരിക്കുന്നത്. ഒരു ഫൈനൽ ടച്ച് എന്നുള്ള രീതിയിൽ കുറച്ച് ക്വസ്റ്റ്യൻസൊക്കെ ഡിസ്കസ് ചെയ്ത് നിങ്ങളുടെ പഠനം എത്രത്തോളം ഉണ്ട് എന്ന് നിങ്ങൾക്ക് തന്നെ വിലയിരുത്താൻ പറ്റുന്ന രീതിയിലുള്ള കുറച്ച് ചോദ്യങ്ങളൊക്കെയാണ് നമ്മൾ ഇന്ന് ഈ വീഡിയോയിൽ ഉൾപ്പെടുത്തിയിരിക്കുന്നത്. അപ്പോൾ നമ്മളിനി പരീക്ഷയ്ക്ക് പോകുമ്പോൾ നിങ്ങൾ പ്രത്യേകം ശ്രദ്ധിക്കുക, ഏറ്റവും പ്രധാനപ്പെട്ട കാര്യം നിങ്ങളിൽ തന്നെ വിശ്വാസം ഉണ്ടാവുക എന്നുള്ളത് തന്നെയാണ്. അപ്പോൾ നിങ്ങളുടെ കഴിവിൽ, നിങ്ങളുടെ പ്രാപ്തിയിൽ, നിങ്ങൾക്ക് ഒരു പരീക്ഷ എഴുതാനുള്ള അല്ലെങ്കിൽ പരീക്ഷ വിജയിക്കാനുള്ള നിങ്ങളുടെ ആ ഒരു ക്ഷമതയിൽ നിങ്ങൾ തന്നെ വിശ്വസിക്കുക, നിങ്ങളിൽ തന്നെ വിശ്വാസം അർപ്പിക്കുക എന്നുള്ളത് തന്നെയാണ് ഏറ്റവും ആദ്യത്തെ കാര്യം. കാരണം നമുക്ക് എന്തെങ്കിലും പറ്റത്തില്ല എന്ന് നമ്മൾ ചിന്തിച്ചു കഴിഞ്ഞാൽ അത് ഒരിക്കലും നമ്മളെക്കൊണ്ട് സാധിക്കുന്ന കാര്യമല്ല. അപ്പോൾ ഇതൊരു ബാരിയറാണ്. ആ ബാരിയർ ചാടിക്കടക്കാൻ ഉതകുന്ന എനർജി അല്ലെങ്കിൽ അത് ചാടിക്കടക്കാൻ ഉതകുന്ന കാര്യങ്ങൾ നമ്മുടെ കയ്യിലുണ്ട്. ആ ഒരു ആത്മവിശ്വാസത്തോടു കൂടി പോയി പരീക്ഷ എഴുതുക. നിങ്ങൾ പഠിച്ച കാര്യങ്ങളിൽ വിശ്വസിക്കുക, പഠിച്ച പ്രോബ്ലങ്ങളിൽ വിശ്വസിക്കുക, നിങ്ങൾ അർപ്പിച്ച ആത്മാർത്ഥതയിൽ വിശ്വസിക്കുക. ദെൻ യു വിൽ ബി റീപെയ്ഡ്. നിങ്ങൾക്കത് തിരിച്ചു കിട്ടിയിരിക്കും. നിങ്ങൾ ആത്മാർത്ഥത കാണിച്ചിട്ടുണ്ടെങ്കിൽ, പഠനത്തിനോട് ആത്മാർത്ഥത കാണിച്ചിട്ടുണ്ടെങ്കിൽ, നിങ്ങൾ കൂടുതൽ സമയം സ്ട്രെയിൻ എടുത്ത് പഠിച്ചിട്ടുണ്ടെങ്കിൽ അതിനൊക്കെയുള്ള പ്രതിഫലം നിങ്ങൾക്ക് ഈ പരീക്ഷയിൽ കിട്ടും, യാതൊരു സംശയവും വേണ്ട. അപ്പോൾ നിങ്ങൾ പോയി പരീക്ഷ എഴുതുക. പിന്നെ നമ്മൾ ഐതിഹ്യങ്ങളിലൊക്കെ പറഞ്ഞിട്ടുള്ളതുപോലെ തന്നെ, ഭഗവത്ഗീതയിലൊക്കെ പറഞ്ഞിട്ടുള്ളതുപോലെ കർമ്മഫലം നോക്കാതെ പോയി പരീക്ഷ എഴുതുക. എന്താണ് റിസൾട്ട് എന്ന് നിങ്ങൾ ഇപ്പോഴേ ചിന്തിക്കേണ്ട കാര്യമില്ല. നിങ്ങൾ അതിനെപ്പറ്റി ബേജാറാവണ്ട, ടെൻഷൻ അടിക്കേണ്ട. നിങ്ങൾ ധൈര്യമായിട്ട് പോയി പരീക്ഷ എഴുതുക. അപ്പോൾ ടെൻഷൻ ഒഴിവാക്കുക എന്നുള്ളത് തന്നെ ഏറ്റവും ആദ്യത്തെ കാര്യം. ടെൻഷൻ വെച്ചാൽ നമ്മൾ പഠിച്ചതെല്ലാം മറന്നു പോകും, ഫോർമുലാസൊക്കെ മറന്നു പോകും, ആകെ കൺഫ്യൂഷനാകും, നമുക്ക് ഒന്നും നമ്മുടെ വരുതിയിൽ നിൽക്കാതെ വരും. അതുകൊണ്ട് ടെൻഷൻ ഒഴിവാക്കുക. പിന്നെ കമ്പ്യൂട്ടർ ബേസ്ഡ് ടെസ്റ്റാണ്. നിങ്ങൾ ചെല്ലുമ്പോൾ കമ്പ്യൂട്ടറിന് എന്തെങ്കിലുമൊക്കെ പ്രശ്നങ്ങൾ പറ്റിയാലോ അല്ലെങ്കിൽ നിങ്ങൾ ചെയ്യുന്ന സമയത്ത് എന്തെങ്കിലും എററുകൾ പറ്റിയാലോ ഒക്കെ അതിനുള്ള ടെക്നിക്കൽ സപ്പോർട്ട് നിങ്ങൾക്ക് അവിടുന്ന് ലഭിക്കുന്നതാണ്. അപ്പോൾ അക്കാര്യത്തെപ്പറ്റി നിങ്ങൾ ടെൻഷനൊന്നും അടിക്കേണ്ട. പെൻ ആൻഡ് പേപ്പറൊക്കെ ആണെങ്കിൽ നമുക്കറിയാം എല്ലാ കാര്യങ്ങളും നമ്മുടെ കയ്യിലാണ്, നമുക്ക് തന്നെ മാർക്ക് ചെയ്യാവുന്നതൊക്കെ ഉള്ളൂ. പക്ഷേ കമ്പ്യൂട്ടർ ബേസ്ഡ് ടെസ്റ്റ് ആകുമ്പോൾ സിസ്റ്റത്തിന് എന്തെങ്കിലും എറർ വരാം, അല്ലെങ്കിൽ എന്തെങ്കിലും പവർ ഫെയിലിയറോ അങ്ങനെ എന്തെങ്കിലുമൊക്കെ വന്നാൽ അവർക്ക് അതിനുള്ള പ്രൊവിഷൻസ് ഒക്കെ ഉണ്ട്. അതിനെപ്പറ്റിയൊന്നും നിങ്ങൾ പേടിക്കേണ്ട കാര്യമില്ല. നിങ്ങളുടെ കാര്യം മാത്രം ചിന്തിക്കുക, അങ്ങനെ പോയി പരീക്ഷ എഴുതുക. പിന്നെ ഇനിയുള്ള സമയങ്ങളിൽ റിവിഷന് കൂടുതൽ പ്രാധാന്യം കൊടുക്കുക. നന്നായിട്ട് റിവൈസ് ചെയ്യുക. പഠിച്ച കാര്യങ്ങൾ എന്തൊക്കെയാണ് എന്ന് ഓർമ്മയിൽ ഒന്നുകൂടെ കൊണ്ടുവരിക. ആദ്യത്തെ കാര്യം മുതൽ അവസാനത്തെ കാര്യം വരെ മുഴുവൻ എല്ലാ ഭാഗത്തുകൂടെയും ഒന്നുകൂടി കണ്ണോടിക്കുക. അപ്പോൾ ഇനി ഒന്നുകൂടെ പഠിക്കാനുള്ള സമയമല്ല, ഒന്ന് കണ്ണോടിച്ച് വിടുക, ഒന്ന് സ്കിം ചെയ്ത് വിടാനുള്ള സമയമാണ് നമുക്ക് ഇനിയുള്ളത്, മുമ്പിലുള്ളത്. അപ്പോൾ എല്ലാ ഫോർമുലാസിലൂടെയും കണ്ടെത്തുന്നുണ്ടെന്ന് ശ്രദ്ധിക്കുക. എല്ലാ സൈനും ശ്രദ്ധിക്കുക. മൈനസ് ആണോ പ്ലസ് ആണോ എന്നുള്ള കാര്യങ്ങളൊക്കെ ശ്രദ്ധിക്കുക. ഓരോ ട്രിക്കുകളും ടിപ്പുകളും പറഞ്ഞു തന്നിരിക്കുന്നത് വീണ്ടും ഒന്ന് ഓർമ്മയിലെടുക്കുക. അങ്ങനെ പഠിച്ച കാര്യങ്ങളിലൂടെ ഒന്നുകൂടൊന്ന് അതിവേഗത്തിൽ കടന്നു പോവുക. അങ്ങനെ റിവൈസ് ചെയ്യുക, റിവിഷൻ കംപ്ലീറ്റ് ചെയ്യുക, മോഡൽ എക്സാമുകളൊക്കെ എഴുതുക, പ്രാക്ടീസ് ചെയ്യുക. കൂടുതൽ പ്രോബ്ലംസ് എവിടെന്നെങ്കിലുമൊക്കെ സംഘടിപ്പിക്കാൻ പറ്റുന്നുണ്ടെങ്കിൽ അവിടെ നിന്നൊക്കെ സംഘടിപ്പിച്ച് ചെയ്തു, യാതൊരു പ്രശ്നമില്ല. പുതിയ കോൺസെപ്റ്റിലേക്കൊന്നും പഠിക്കാനുള്ള സമയമില്ല. ഇനി ചിലർക്ക് അങ്ങനെ പഠിക്കാൻ കഴിവുള്ളവരുണ്ട്, തലേന്ന് വരെ എല്ലാം കുത്തി നിറച്ച് പഠിക്കാൻ കഴിവുള്ളവരും ഉണ്ട് കേട്ടോ. അപ്പോൾ അവരെയൊന്നും വില കുറച്ച് കാണുകയല്ല, അവർക്ക് അത് തുടരാം, നിങ്ങളുടെ സ്വാതന്ത്ര്യമാണ്. അപ്പോൾ അതുകൊണ്ട് പക്ഷേ ഒരു ജനറലൈസ് ചെയ്ത് പറയുവാണെങ്കിൽ പുതിയതായിട്ട് കാര്യങ്ങൾ പഠിക്കാൻ പോകാതിരുന്നിട്ട് റിവൈസ് ചെയ്യാനും കൂടുതൽ നമ്മൾ പഠിച്ച ഭാഗത്തു നിന്നുള്ള പ്രോബ്ലംസ് കൂടുതൽ വർക്കൗട്ട് ചെയ്യാനുമുള്ള സമയങ്ങളാണ് ഇനി നമ്മുടെ മുമ്പിലുള്ളത്. അക്കാര്യങ്ങൾ പ്രത്യേകം ശ്രദ്ധിക്കുക. ഓർമ്മ പശകൾ ഉണ്ടാകാതിരിക്കാനുള്ള വഴി നിങ്ങൾ കണ്ടെത്തുക. അതിന് മറ്റേ ബ്രഹ്മി കലക്കി കുടിച്ചിട്ടൊന്നും ഒരു കാര്യമല്ല. പക്ഷേ നമ്മൾ വായിച്ച് പഠിക്കുക, വീണ്ടും നമ്മൾ പഠിച്ച കാര്യങ്ങളിലൂടെ വീണ്ടും ഒന്ന് കടന്നുപോയി ഫോർമുലാസൊക്കെ ഓർത്ത് വെക്കുക. സൈനൊക്കെ ഞാൻ മുമ്പേ പറഞ്ഞതുപോലെ സൈനൊക്കെ പ്രത്യേകം ഓർക്കണം. നമുക്ക് എക്സാം ഹോളിലൊക്കെ കയറി കഴിയുമ്പം ഈ സൈനിലൊക്കെയാണ് നമുക്ക് ഏറ്റവും പ്രശ്നം വരുന്നത്. ഇ റൈസ്ഡ് പ്ലസ് എക്സ് മൈനസ് എക്സ് ഐ പ്ലസ് ഐ എക്സ് മൈനസ് ഐ എക്സ് സൈൻ എച്ച് എക്സ്, അതൊക്കെ അതിൻ്റെയൊക്കെ ഫോർമുല മറന്നു പോകാനൊക്കെ സാധ്യതയുണ്ട്. സൈൻ തീറ്റ ഇ റൈസ്ഡ് വൈ തീറ്റ മൈനസ് ഇ റൈസ്ഡ് മൈനസ് ഐ തീറ്റ ബൈ 2i, അത് ചിലപ്പോൾ 2i എന്നൊക്കെ ഉള്ളത് നമ്മൾ ചിലപ്പോൾ മറന്നു പോയെന്നിരിക്കും. മൈനസ് നടക്കുന്ന മൈനസൊക്കെ ചിലപ്പോൾ നമ്മൾ വിട്ടുപോയെന്നിരിക്കും. അപ്പോൾ അങ്ങനത്തെ പല പ്രശ്നങ്ങളും നമുക്കൊക്കെ ഉണ്ടാകാൻ സാധ്യതയുണ്ട്. അത് എനിക്കുണ്ടായിട്ടുള്ളതാണ്, അതുകൊണ്ടാണ് ഞാൻ വ്യക്തമായിട്ട് നിങ്ങളോട് പറയുന്നത്. അപ്പോൾ അതുകൊണ്ട് ഫോർമുലാസൊക്കെ ഹൃദയസ്ഥമാക്കാനായിട്ട് പ്രത്യേകം ശ്രദ്ധിക്കുക. അപ്പോൾ വളരെ നല്ലൊരു എക്സാം നിങ്ങൾക്ക് ആശംസിക്കുന്നു. അപ്പോൾ പഴുതടച്ച ഒരു എക്സാം ആയിരിക്കും അവർ ഇത്തവണ ഒരുക്കുക. അപ്പോൾ അതുകൊണ്ട് അക്കാര്യത്തിലൊന്നും സംശയം വേണ്ട. വളരെ നല്ല രീതിയിൽ പോയി എക്സാം എഴുതാൻ പറ്റട്ടെ, എല്ലാ കാര്യങ്ങളും ഓർമ്മയിൽ കിട്ടട്ടെ, പഠിച്ച കാര്യങ്ങളൊക്കെ ഉപയോഗിക്കാൻ പറ്റട്ടെ. എല്ലാ വിജയാശംസകളും നേരുന്നു. സോ നമുക്ക് നമ്മുടെ വീഡിയോയിലേക്ക് പോകാം. സോ നോക്കുക, നമ്മുടെ ഫസ്റ്റ് ക്വസ്റ്റ്യൻ. എ സിസ്റ്റം ഓഫ് spin half particles is prepared to be in the eigen state of sigma x with eigenvalue plus 1. The system is rotated by an angle of 60 degree about the x-axis. After the rotation, the fraction of particles that will be measured to be in the eigen state of sigma z with eigenvalue plus 1 is. ഇതാണ് നമ്മുടെ ചോദ്യം. നോക്കുക, initially my system, I have a system of a spin half particles, and initially it was in the eigen state of a sigma x with eigenvalue plus 1. You should know what are the Pauli spin matrices and what are its eigen vectors and what are the eigen values. Okay. So then after that initial preparation, we rotated the system by an angle of about 60 degree about the x-axis, and after the rotation we have to find the fraction of particles that could be in the eigen state of a sigma z with eigenvalue plus 1. Okay. So let us now discuss this. So we know the rotation about x-axis, the rotation about x-axis at an angle theta, is represented as the unitary rotation operator r of theta. We know the unitary rotation operator r of theta equals e raised to or exponential minus I theta by 2 dot sigma, e raised to minus I theta by 2 dot sigma, isn't it? So now what happens, or we know the rotation, it could also be represented as u of r theta equals u of r theta equals e raised to minus I. So e raised to I theta is what? Cos theta plus I sin theta. So it is cos theta by 2 I minus I sin minus I sin theta by 2 dot sigma. Minus I sin theta by 2 dot sigma. It is in theta cap direction. Clear? So now we have to come to our point. The rotation operator with respect to x-axis at an angle of theta, isn't it? U of rx theta equals cos theta by 2 I minus I sin theta by 2 into theta cap dot sigma becomes sigma x, isn't it? Clear? So theta cap into theta cap dot sigma x. Okay. So then we know this rx of theta equals now just multiply this with the respective cos theta into I. Cos theta I means cos theta by 2 into I means 1 0 0 1. So and minus I into sin theta by 2 into sigma x. You know what how sigma x is written. You know the form of a sigma x. Again I would like to say that you have to, I would like to stress the point, you have to make it clear what are Pauli spin matrices and what are its properties and how they are related and what are the commutation relations. All those things you should keep in mind. Okay. All the properties of Pauli spin matrices are discussed. So So you should go through that again. Some 8 or 9 properties are there. Okay, so you should keep in mind. So Rx of theta could be written as what? Here it will be cos theta by 2 and this will be cos theta by 2. 1 0 0 1 and minus I sin theta by 2. 0 minus 1 1 0, isn't it? So minus into minus it will be plus. So it will be so this will be what? I sin theta by 2 and this will be minus I sin theta by 2, minus I sin theta by 2, isn't it? So now it is rotated by an amount 60 degree. So put theta equals, you have to put the theta equals 60 degree or pi by 3. So just to put theta equal to pi by 3. So what will happen? So Rx of theta equals, so Rx of theta equals what will you get? Cos pi by 6. So pi by 6 means cos 30. Cos 30 is what? It is root 3 by 2 and sin 30. Sin 30 is 1 by 2 and I is there, so it is I by 2 and minus I by 2, isn't it? And here cos theta by 2 it will be again root 3 by 2. So you got root 3 by 2, I by 2 minus I by 2 root 3 by 2. This is my rotation operator at an amount when it is rotated about an angle 60 degree. Clear? So then what happens? Now we have to go through. Now we have to go to the eigenstate. So get psi of theta. Get psi of theta equals. Get psi of theta equals. What happens? Rx of theta into, it was in the eigenstate of sigma x with eigenvalue plus 1. So what is that? So it will be 1 0. So this is the eigenstate 1 0, isn't it? So Rx of theta into 1 0 which is equal to, you got Rx of theta. What is Rx of theta? It is root 3 by 2 I by 2 minus I by 2 and root 3 by 2 multiplied with 1 0. Multiplied with 1 0. Then what will you get? Psi of theta. Get psi of theta equals, so root 3 by 2 into 0 then minus I by 2. Minus I by 2 into 0. So it will be minus I by 2. So you got the state vector as root 3 by 2 minus I by 2. Is it clear? Just a matrix multiplication only and you will get the resultant state. So get the psi equals root 3 by 2 minus I by 2. So now what will happen? You have to find the particles measured in the eigenstate of sigma z with the eigenvalue plus 1. So it should be in the sigma z state with eigenvalue plus 1. So I can expand this in terms of sigma z. So then how can I write? Then get psi equals root 3 by 2 into 1 0 then minus I by 2 into 0 1, isn't it? I could expand my eigenstate with respect to the basis vectors. The basis vectors of sigma z. Basis vectors of sigma z. So 1 0 corresponds to eigenvalue plus 1. 0 1 corresponds to eigenvalue minus 1. We have studied it earlier, isn't it? So psi equals root 3 by 2 1 0 minus I by 2 into 0 1. Now what are these? These are the coefficients, isn't it? So these are the coefficients. So these coefficients represents probability amplitude and the modulus square of probability amplitude will give you what? Will give you the probability. So what is the question? You have to find the fraction of particles or what the probability of particles in the eigenstate of sigma z with eigenvalue plus 1. So eigenvalue plus 1 it corresponds to the probability amplitude root 3 by 2 and the probability of 3 by 4, isn't it? And with eigenvalue minus 1 in the eigenstate of sigma z, then the probability amplitude will be minus I by 2 and the probability will be modulus square of I by 2, it will be 1 by 4. Is it clear? So you have to know the difference between the probability and the probability amplitude. How the probability is calculated from the probability amplitude. How the probability amplitude comes. These all are explained in the introductory part of our quantum mechanics. Please go through that. Okay. So we can say that if sigma z is measured, if sigma z is measured on the state vector, we can say that the probability with plus 1 is 3 by 4, and the probability with value minus 1 is I by 2 mod square, it will be 1 by 4. So 3 by 4 plus 1 by 4 will be 1. You can see here the 3 by 4 plus 1 by 4 will be 1. So this state vector is also normalized. Clear? So I hope this problem is very clear, and to do this problem you should have you should be well knowledgeable about the properties of Polish spin matrices and the rotatory, unitary, rotatory or rotation operators and such other things. Okay, so this is, I hope this is very clear to you, and you have to practice this problem more. Okay, also there are chances that they may ask beautiful questions from angular momentum algebra, especially from spin algebra. Okay, so that is very very important. ഒത്തിരി ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഭാഗമാണ് സ്പിൻ ഓൾജിബ്ര. അതിനകത്തുനിന്ന് അവർ ഇതുപോലെ ഒരു ഇനീഷ്യൽ സ്റ്റേറ്റ് ഉണ്ടാക്കും. They will cook an initial state and then they will do something, they will rotate something, they will rotate with respect to some axis, and we will be asked to calculate the probability of a final state. Final state will be something, isn't it? Initial state ഉണ്ടാവും, എന്നിട്ട് അതിനെ കുക്ക് ചെയ്തിട്ട് ഫൈനൽ സ്റ്റേറ്റ് ആക്കും, എന്നിട്ട് നമ്മളോട് അതിൻ്റെ പ്രോബബിലിറ്റീസ് കാൽക്കുലേറ്റ് ചെയ്യാൻ പറയും. അങ്ങനെ പല ചോദ്യങ്ങളും ഉണ്ടാവും. So you should practice well. The questions from angular momentum algebra, especially from spin algebra. Clear? So I hope this problem is clear to you. Okay, so now let us move into our next one. So a two-state system evolves under the action of a Hamiltonian H equals E0 into AA plus E0 plus delta into B, where ket A and ket B are its two orthogonal states of that system. These states transform to one another under parity given by parity operator acting on A will give you B, and parity operator acting on B will give you A. If at a time t equal to 0 the system is in a state of definite parity p equal to 1, the earliest time at which the probability of finding the system in a state of parity p equal to minus 1 is. See the question. So go through the question once again. You are given a Hamiltonian. The Hamiltonian is given like this. So the Hamiltonian is represented in a matrix form, isn't it? So these are the matrix elements, you know. So it is given in the matrix form so that we can calculate the eigenvalues very easily. So moreover, when we think about the matrix representation, we can say that these values are in the diagonal elements only. So they are the diagonal. So it becomes a diagonal matrix. Then these are orthogonal states. This is given, and the main thing is these states transform to one another under parity. When the parity operator acts on one state, we will get the another orthogonal state, and when the parity operator acts on that state, we will get the first state. In that way it goes. It is the specialty of the system. So at a time t equal to 0, they have given that the system is in the parity p equal to 1, and we have to find the next time at which the system is at the parity minus 1. Okay, so we have to find out that time. So let us move and find out the time. So what is a Hamiltonian? The Hamiltonian H is given as E0 into A plus E0 plus delta into B, isn't it? So I can write it as in the matrix form. The Hamiltonian is given as how can you write it in the matrix form? This be my ket A, this be my ket B, and this is my bra side, and this is bra B. So A into A is E0, AB is 0, then BA is 0, and BB is what? It is E0 plus delta. E0 plus delta. Clear? So now this, you can see that this is a diagonal matrix, and the eigenvalues, the energy eigenvalues, the eigenvalue will be the eigenvalue will be the energy itself, because this is a Hamiltonian operator. So the energy eigenvalues, so the energy eigenvalues, so the energy eigenvalues can be given as energy eigenvalues lambda, let it be lambda. Lambda is equal to, what are the eigenvalues? The eigenvalues are the, for a diagonal matrix, the eigenvalues are the diagonal elements itself, isn't it? So it is E0 comma E0 plus delta, E0 plus delta. So we got the energy eigenvalues. So we can say that the eigenfunction of the system, the eigenfunction of the system, the eigenfunction of the system at time t, eigenfunction of the time t, that means some phi of t, some phi of t equals first state is a, isn't it, e raised to minus I E1, E1 is E0 into t by h cross plus b into e raised to minus I into E0 plus delta into t by h cross. So because this is the second energy, isn't it? So I got the state. So I got the eigenstate corresponding to this Hamiltonian at a time t. So a into e raised to minus I E0 t by h cross plus b into e raised to minus I E0 plus delta into t by h cross. And it is given that when the parity operator, we know the parity operator is represented by pi, and when the parity operator acts on A, when the parity operator acts on A, we will get B, isn't it? It is given. So when the parity operator acts on my state, when the parity operator acts on my state, what will get? What will I get? I will get minus phi of t, isn't it? When the parity operator acts on this this state, I will get minus pi of t. That is how parity operator acts. It's clear. So pi over pi acting on phi of t equals minus phi of t. Okay. So then what will happen? So so I am applying this parity operator into this. So what will get? What will I get? Pi operating on a e raised to minus I E0 t by h cross plus pi operating on b e raised to minus I E0 plus delta into t by h cross, E0 into t by E0 plus delta into t by h cross. So also pi acting on A will give you B, isn't it? So so what will you get? So also this will be negative. Clear? You should not forget the basic factor of pi, the parity operator. You will get the reverse parity, isn't it? Should be negative. So this will give you what? This equals then pi acting on A. So this will be what? Also, isn't it? Minus is there. So minus pi acting on A e raised to minus I E0 into t by h cross minus pi acting on B e raised to minus I E0 plus delta into t by h cross, E0 plus delta into t by h cross, isn't it? So see, then what will happen? So this implies pi acting on A, it will give you ket B e raised to minus I E0 into t by h cross plus this will be ket A e raised to minus I E0 plus delta into t by h cross, E0 plus delta into t by h cross. Clear? Then we have to equate the we have to equate or compare the coefficients, compare the coefficients of ket A and ket B. So we should compare the coefficients. So when you compare the coefficients, see B, if you take the case of A, here the coefficient is minus e raised to minus I E0 into T by H cross is equal to e raised to minus I E0 plus delta into T by H cross. Then what about B? Here it will be e raised to minus I E0 into T by H cross equals minus e raised to minus I E0 plus delta into T by H cross, isn't it? So we can say that both equations are same, isn't it? Both are same. Since both of these conditions are same, we can write minus e raised to minus I E0 into T by H cross equals e raised to minus I E0 plus delta into T by H cross. Okay. So what will happen? So so now is just pure mathematics only. So now I have to take this here. So e raised to minus I into E0 plus delta into T by H cross. This will be 1 by e raised to I E0 T by H cross. That will go here. So into e raised to I E0 into T by H cross equals what? Equals minus 1, isn't it? So what will you get? E raised to minus I, see, minus I E0 into T by H cross into e raised to I E0 into T by H cross into e raised to minus I delta into T by H cross equals minus 1. What is minus 1? It is e raised to I pi. We have seen it several times. It is e raised to I pi, isn't it? So this and this will cancel. Okay. So what will you get? So e raised to minus I into delta into T by H cross equals e raised to minus I pi. Okay. So since the base are same, since the base is same, you can equate the powers. So minus I delta into T by H cross equals minus I pi. So minus I and minus I cancels, and what will you get? Time T equals, and what will you get? Time T equals H cross pi by delta. So this is the shortest time after which you will get the parity minus 1. Is it clear? So we just we just wrote the Hamiltonian, we calculated the eigenvalues, and using that eigenvalues we expressed an arbitrary state in at a time t, e raised to minus I E1 T by H cross, e raised to minus I E2 T by H cross. We substituted E1 and E2 and we got the state, and then we applied the parity operator. The parity operator has been applied. Then after applying the parity operator, we got the results, isn't it? And we applied the conditions of parity operator which is given in the question, and we switched the states, and then we equated the coefficients. Then after equating the coefficients, we did pure mathematics, and we got time t equal to H cross pi by delta. Is it clear? I hope this problem is understood. Then shall we go to the next one? See the next one. See, the total time of phonon modes in a solid of volume V is integral 0 to omega d g of omega d omega equals 3n, where n is the number of primitive cells and omega d is the Debye frequency, and the density of phonon modes is given by g of omega equals AV into omega square with the constant A greater than 0. If the density of the solid doubles in a phase transition, the Debye temperature theta d will. So what will happen to the Debye temperature? So in the solid state physics, the Debye model, Einstein model, these two models are very, very important while you study the specific heats. So you have to study in depth. Okay. So there all the relations are very important, you should keep in mind. Okay. So now when the density of the solid doubles in the phase transition, we have to calculate what will happen to the Debye temperature. Okay. So, whether it increase by a factor of 2 raised to 2 by 3, whether it is decreasing by a factor of 2 raised to 1 by 3, or increasing or decreasing, we have to find out. Okay. So, let us find out. So, we know the Debye temperature. What is Debye temperature? The Debye temperature. The Debye temperature is given by theta d equals Debye temperature theta d is equal to h nu by kb into 6 pi square into n by v raised to 2 by 3 n by v raised to 1 by 3 n by v raised to 1 by 3 h nu by kb into 6 pi square into n by v raised to 1 by 3. Is it clear? So, then this can be written as h nu by kb into 6 pi square delta, or 6 pi square into the number the number density, isn't it, raised to 1 by 3, 6 pi square n raised to 1 by 3, could be written like this. So, then so I can say that the Debye temperature theta d, h nu by kb is a constant, 6 pi square is a constant. So, the constant all constants could be written as a into n power 1 by 3 into n power 1 by 3. This is a simple one. So, theta d equals a into n power 1 by 3. So, if the density is doubled, if the density is doubled, you can say that n prime, the number density will becomes 2n, the number density will become 2n, isn't it? So, then what will happen? You have to substitute it here. So, theta d prime will be equal to a into 2n power 1 by 3, a into 2n power 1 by 3. So, what will happen? This is equal to a into 2 raised to 1 by 3 into n raised to 1 by 3, and then a into n raised to 1 by 3 is what? This theta d. So, theta d prime equals 2 power 1 by 3 into theta d. So, theta d prime equals 2 raised to 1 by 3 into theta d. So, we can say that the Debye temperature increases by a factor of 2 power 1 by 3. The Debye temperature increases. The Debye temperature increases by a factor of 2 power 1 by 3. Okay. So, you should know what are those three, Dulong-Petit's law, Einstein's law, and or Einstein's model or Debye model, and why, what are the drawbacks of Dulong-Petit's law, what are the drawbacks of Einstein's law, and how these two drawbacks were overcome in Debye model, and what are the temperature ranges where all these models are applicable, and how they are related, and what are their expressions. All these things you should revise again. Okay. So, in solid state physics, the specific heat is very, very important topic. So, you should revise it again, and you have to keep it thorough. Okay. So, the problems may come like this, may not be that much numerical type, but this kind of finding relations will appear, and these have been appearing frequently in almost all exams. So, even for the set exams too, they will be asking these kind of questions. Okay. So, this is one important model. Okay. So, I hope this problem is understood, and shall we go into the next one? So, next one, see, the unnormalized wave function of a particle in one dimension in an infinite square well with walls at x equal to 0 and x equal to a is psi of x equals x into L minus x. So, if psi of x is expanded as a linear combination of energy eigenfunctions, then integral 0 to a psi of x mod square dx is proportional to the infinite series. So, we have to find the expansion of this one as linear series. Okay, so let us see. While reading the question, you have to read the question word by word very carefully. See, this is unnormalized wave function of a particle in one dimensional infinite square well with walls at x equal to 0 and x equal to, let it be x equal to L, x equal to 0 and x equal to L is psi of x equals x into L minus x. Then we have to expand psi of x. See, the expansion of psi of x we have studied in the properties of wave function, how they are expanded. There will be an expansion coefficient followed by the base state. Okay, so then we have to find that expansion as proportional to some infinite series, and what is that infinite series. So this is the question. So now let us move into the answer. See, so you are given psi of x, you are given psi of x at a time t equal to 0 as what? Psi of x as x into L minus x, x into L minus x, and our first aim is to make this unnormalized wave function as a normalized one. So we have to normalize it. I hope in our classes we have normalized the same wave function, and those who have practiced our questions may definitely know the answer of this normalization constant. It will be under root 30 by a power 5, isn't it? So, if you don't know, we can normalize it again. So, to find the normalization, first you have to normalize. So, normalization equals integral from where to where? Integral 0 to a into a square into x square into L minus x whole square dx equals 1. So, a square into integral 0 to a into x square into L square minus 2xl plus x square into dx equals 1. So, a square into integral 0 to a x square into x square L square minus 2x cube L plus x power 4 dx equals 1. Then integrate 1 by 1. So, a square into L square into x cube by 3 minus 2 into x raised to 4 L by 4 plus x raised to 5 by 5 from where to where? 0 to a. This will be equal to 1. Clear? So, a square into if you apply the upper limit, it will be a power 5 by 3 minus a power 5 by 2 plus a power 5 by 5 equals 1. So, then what will happen? So, a square into a power 5, a power 5 can also be taken outside, isn't it? So, a square into a power 5 into 1 by 3 minus 1 by 2, 1 by 3 minus 1 by 2 plus 1 by 5 equals 1. So, a square into a power 5 into 1 by 3 minus 1 by 2, what it will be? 2 minus 3 by 6. So, it is a minus 1 by 6 plus 1 by 5. So, it is 5 minus 5 plus minus 5 plus 6, 1 by 30 equal to 1, isn't it? So, a square a power 5 into 1 by 30 equals 1, and you will get a is equal to under root 30 by a power 5, for those who don't know how to normalize. Clear? So, you go to the normalization constant. So, you can write the wave function as what will be the wave function? The normalized wave function psi of x equals under root 30 by a power 5 into x into L minus x, x into L minus x. So, you got the normalized wave function. So, now we can expand, we expand the wave function psi of x in terms of eigenstates or base states. We expand psi of x in terms of base states. Okay. So, I can say that psi of x is equal to psi of x is equal to summation n equal to 1 to infinity, what it will be, Cn into psi n of x, Cn into psi n of x. Now our aim is to find the expansion coefficient Cn. Okay, so now how to find the expansion coefficient? So we multiply this with multiply with psi n star. We multiply with psi n star of x and integrate. So when you multiply with the psi n star of x and integrate, psi n star into psi n will be 1. So Cn will be equal to integral from where to where? From 0 to L. From 0 to L, isn't it? So 0 to L, psi n star of x into psi n of x dx, psi n of x dx, isn't it? Psi n of x into psi n star of x into psi n of x. We got psi n of x here, and psi n star of x. What is psi n star of x? Psi n star of x is for the one dimensional box, you know, under root 2 by L sin n pi x by L, isn't it? So Cn equals integral 0 to L, psi n star will be under root 2 by L sin n pi x by L into this will be under root 30 by L power 5. Sorry, this is better, it could be written as L power 5, isn't it? So this is some L power 5. So root L power 5. So now then under root L power 5 into x into L minus x dx, x into L minus x dx. So take out the constants. So what are the constants? 30. So Cn equals 30 by L power 5 power 1 by 2 into 2 by L power 1 by 2 into integral 0 to L x into L minus x into sin n pi x by L dx. See how complex the integration is. So now we will use the change of variable method. So we will just change the variable, change the limit, and then we will apply. Okay. So we now put y equals some pi x by L. Y equals pi x by L, and what will be dy? Dy equals pi by L into dx. Pi by L into dx. So then the limit will change into what? So if it is x, it was from 0 to L, and if it is y, if you substitute 0, this will be 0, and if you substitute L, then it will be pi, isn't it? So then Cn will be equal to 30 into 2, 60 by this one will come. So what will be? It will be 2 root 15, isn't it? 2 root 15. So root 60 divided by this will be dy will be there, and then L power 6, one L cube will be there, and that L cube goes, isn't it? That L cube vanishes, and what will come? There will be this pi square will come here, isn't it? Pi square into integral 0 to pi into integral 0 to pi. This will be L minus x. So what is x then? X is Ly by pi. So x is Ly by pi. So if you substitute Ly by pi into L minus Ly by pi, so this will be 1 minus y into y into 1 minus y by pi, isn't it? 1 minus y by pi, is it not? So y into 1 minus if you take this L into L, that is L square, then one L will come here. So the L cube, that L cube and L cube cancels, that pi square comes here, So y into 1 minus y, 1 minus y by pi into sin ny dy, sin ny dy, isn't it? So you got Cn. So we know, we have studied, I have taught you the integral 0 to pi y into sin ny dy, integral y into sin ny dy equals minus pi by n into minus 1 raised to n, minus 1 raised to n. It's a standard integral only. So moreover 0 to pi, integral 0 to pi y into y square, isn't it? Y square sin ny dy, y square into sin ny dy equals minus pi square by n, minus pi square by n into minus 1 raised to n plus 2 by n square into minus 1 raised to n minus 1. I have told you, you have to study these all standard integrals. See, y sin ny dy, y into y square sin ny dy, y square sin ny dy is minus pi square by n into minus 1 raised to n, 2 by n square, minus 1 raised to n minus 1. See, there is a pi square and here there is pi and pi cancels. So what will you get? So minus 1 minus pi by n into minus 1 raised to n. So minus into minus will be plus, these two terms will cancel, and what will remain? 2 by n square minus 1 raised to n minus 1 will only remain. Clear? You just write it and then you can find it out. I am just simplifying it myself. So then what will be my Cn? Cn will be equal to, then Cn will be equal to this will be there comes a 2, then 2 and the constant 2, that will be 4 root 15, isn't it? 4 root 15 by pi square into that there will be that n into n, that n square into n, that will be n cube, then n cube into 1 pi is also there, isn't it? So that is a pi cube n cube into pi cube n cube into 1 minus that minus 2 by n, minus I have taken that minus inside. So 1 minus minus 1 raised to n, 1 minus minus 1 raised to n. You just write it down in your paper and just calculate it. You will get this. Okay. So 4 root 15 by pi cube into n cube divide into 1 minus minus 1 raised to n. So what is the probability then? So this is Cn, coefficient of expansion. Then what is the probability? Probability, I have told you in the first question, probability is the square of the coefficient. The coefficients will be the probability amplitudes. So probability will be mod Cn square. So it will be what? It will be 16 into 15. 16 into 15. So 16 into 15. What will be 16 into 15? 30, 80, 61. So it is 240, isn't it? So that is 240 by pi raised to 6 into n raised to 6 into into 1 minus minus 1 raised to n whole square. So this is the probability. So 240 by pi raised to 6 into n raised to 6 into minus 1 into 1 minus minus 1 raised to n whole square. Is it clear? So we can see that the probability is proportional to n raised to minus 6. The probability is proportional to n raised to minus 6. The question is about so if psi of x is expanded as a linear combination of energy eigenfunctions, then integral 0 to a mod psi square is proportional to the infinite series, and the options are here summation n equal to 1 to infinity, 2n minus 1 raised to minus 6, and summation n equal to 1 to infinity 2n minus 1 raised to minus 4, then summation n equal to 1 to infinity 2n minus 1 raised to minus 2, then fourth one summation n equal to 1 to infinity 2n minus 1 raised to minus 8. 2n minus 1 raised to minus 8. So, out of these 4 options, the most agreeable one is the first one, isn't it? So, it is n raised to minus 6. The probability is proportional to n raised to minus 6. So, the first one will be the answer. Is it clear? So, we see how they have framed the questions just based on the expansion of wave functions using the basis state. So, you have to you should learn how to calculate the expansion coefficients and how to expand it and how to integrate to find out the expansion coefficient, and then how to relate them into an infinite series expansion. Clear? So, this is one of the new types. So, you should solve this again, should study this. Clear? So, I hope it is very clear to you and you have understood this. Then we shall move into the next one. See, in the reaction, proton plus neutron will give giving proton plus some K plus X mediated by strong interaction. The baryon number B, strangeness S, and the third component of isospin I3 of the particle X are respectively. So, this is from nuclear physics, and you know in the particle physics more specifically, and you know in the particle physics, instead of asking the different quantum numbers of an unknown particle, they have given you like this. So, in this reaction you should be able to balance the quantum numbers on the left side and the right side, and then you have to find the quantum numbers which are given for the unknown one. And moreover, in some questions, after finding out these all quantum numbers, they may ask you what particle is that. In that way also the question can come. So, while studying particle physics, you should study in such a way that you should know all the quantum numbers for each particle, and in the reverse manner, by giving the quantum numbers you have to identify the particles also. Okay. So, I have told this several times. You should take a single sheet of paper and all the particle divisions should be written in a single sheet, so that a single glance will give you the total summary of that entire portion. Okay. You should divide this baryon lepton, what is the baryon number, what is the strangeness number, what is the isospin, and such all other things for each particle should be written there. Okay. And all the classification, subclasses, everything should be written, neatly written, so that you should not turn many pages to recollect all those things. Okay. So, that is very, very important. So, now let us solve this problem. So, what is the reaction here? So, the reaction is proton plus neutron giving you the K plus particle plus the unknown one, K plus particle, proton plus the unknown one, isn't it? So, now proton plus K plus the unknown one, isn't it? Now, write down what all things you are needed. First one, they have to they need the baryon number of this unknown particle. So, you know the baryon number of proton, it is 1, baryon number of neutron is 1, and the baryon number of proton is 1, and the baryon number of K plus it is 0, since it is not a baryon. And see here the baryon number is a total, it is a 2, and here it is only 1. So, to balance 2 and 1 you need another 1 here, isn't it? Next, what they have asked? They have asked the strangeness. So, proton is not a strange particle, neutron is not a strange particle, again proton in the daughter side is not a strange particle, then K plus the strangeness is 1, strangeness is 1. So, see here the strangeness is 0, here the strangeness is 1 now. So, in order to balance 0 and 1 you need minus 1 here, minus 1 here. Okay. So, the strangeness is minus 1. Then you have to find the third component of isospin. So, what is the third component of isospin? So, you know the third proton, it is having proton is having plus half, neutron is having minus half, proton is having plus half, and K plus is having plus half, isn't it? K plus, K0, K minus. So, this is having plus half. then so see here it is a 0, here it is a 1, so the strain the I3 should be here it is a 0, here half plus half is 1, so you should have minus 1. So what are the quantum numbers required? 1, minus 1 and minus 1. Is it clear? So this is the required configuration for the unknown particle, quantum number configuration for the unknown particle. Is it clear? Understood? So you should learn the quantum numbers, and also you should know what are the classifications of the different particles. Clear? So we will be moving into the next one. Before moving into the next one, നമ്മൾ CSIR ഫിസിക്സ് ഡിസംബർ ബാച്ചിലേക്കുള്ള അഡ്മിഷൻ, ലോങ് ടേം ബാച്ചിലേക്കുള്ള അഡ്മിഷൻ ആരംഭിച്ചിരിക്കുന്നു. നമുക്കറിയാം ഏറ്റവും എഫക്റ്റീവായിട്ട് നിങ്ങൾക്ക് CSIR ഫിസിക്സ് പഠിക്കാൻ ഏറ്റവും നല്ലത് ലോങ് ടേം ബാച്ച് തന്നെയാണ്. തീരെ സമയമില്ലാത്തവർക്ക് വേണ്ടി അവർക്ക് വേണ്ടിയാണ് നമ്മൾ 60 ഡേയ്സും 90 ഡേയ്സും ക്രാഷ് ബാച്ചും ഒക്കെ നമ്മൾ ആരംഭിക്കുന്നത്. ഏറ്റവും നന്നായിട്ട് സ്റ്റഡി സ്ട്രാറ്റജി ഫോളോ ചെയ്യാൻ പറ്റുന്നതും ഏറ്റവും എഫക്റ്റീവായിട്ട് നിങ്ങൾക്ക് പഠിക്കാൻ പറ്റുന്നതും ലോങ് ടേം ബാച്ച് തന്നെയാണ്. ബിക്കോസ് യു വിൽ ഗെറ്റ് ആമ്പിൾ ബ്രീത്തിങ് ടൈം ഇൻ ബിറ്റ്വീൻ. അല്ലെങ്കിൽ ഭയങ്കര തിക്ലി പാക്ഡ് ആണ്. സോ യു വിൽ ബി ഗിവൺ സ്റ്റുഡിയോ റെക്കോർഡഡ് ക്ലാസ്സസ്, കംപ്ലീറ്റ് സിലബസ് വിൽ ബി കവേർഡ്, ലൈവ് സെഷൻസ് വിൽ ബി ഗിവൺ, എക്സ്ട്രാ ലൈവ് സെഷൻസ് വിൽ ബി ഗിവൺ. ഓൾമോസ്റ്റ് ഓൾ ഡേയ്സ് എന്ന കണക്കിന് നമ്മൾ ലൈവ് സെഷൻസ് ഉണ്ടായിരിക്കും. 1 മണിക്കൂർ 2 മണിക്കൂർ അങ്ങനെ പോകുന്ന ലൈവ് സെഷൻസ് ഉണ്ടായിരിക്കും. അപ്പോൾ ലൈവ് സെഷൻസിൽ ദേ ആർ ഡെഡിക്കേറ്റഡ് ടു എക്സ്ക്ലൂസീവ് പ്രോബ്ലം സോൾവിങ്, സോ യു ക്യാൻ ജോയിൻ ഫോർ ദാറ്റ്. ദെൻ സ്റ്റഡി മെറ്റീരിയൽസ് വിൽ ബി പ്രൊവൈഡഡ്. ഡൗട്ട് ക്ലിയറൻസ് you can ask your teacher directly regarding your doubt. Then ടീച്ചർ നിങ്ങളിൽ നിന്ന് അകന്നു നിൽക്കുന്ന അല്ലെങ്കിൽ നിങ്ങൾക്ക് റീച്ചബിൾ അല്ലാത്ത ഒരാളല്ല കോമ്പറ്റേറ്റീവ് ക്രാക്കറിലെ നിങ്ങളുടെ ടീച്ചർ. യു ക്യാൻ കോൺടാക്ട് ദ ടീച്ചർ ഡയറക്ട്ലി. ദെൻ ദ എക്സാംസ് വിൽ ബി ഗിവൺ. The only thing is you should take the exams seriously and make sure that you attend without fail. Okay. Then the question reviews, the previous year questions will be discussed while the classes, and also in the live sessions, and also will be given to you in your exams. So you will be solving all the previous year questions, almost all previous year questions in the during this course. Okay, ഇതൊക്കെയാണ് നമ്മുടെ കോഴ്സിൻ്റെ സവിശേഷതകൾ. അപ്പോൾ നിങ്ങൾക്ക് CSIR ഫിസിക്സ് ക്രാക്ക് ചെയ്ത് ഒരു നല്ല പ്രസ്റ്റീജിയസ് ആയിട്ടുള്ള അസിസ്റ്റൻറ്റ് പ്രൊഫസർ എന്ന് പറയുന്ന ഒരു പോസ്റ്റിലേക്കോ റിസർച്ച് എന്ന് പറയുന്ന ഒരു മേഖലയിലേക്കോ ഒക്കെ പോകണമെന്നുണ്ടെങ്കിൽ തീർച്ചയായും നിങ്ങൾക്ക് നെറ്റ് ക്ലിയർ ചെയ്തേ പറ്റൂ. അപ്പോൾ റിസർച്ചിന് വേണ്ടി പോലും ഇത്തവണ അഡ്മിഷൻസ് ബേസ് ചെയ്തിരിക്കുന്നത് ഈ പരീക്ഷയെ ബേസ് ചെയ്തിട്ടാണ്, ഈ പരീക്ഷയുടെ റിസൾട്ടിനെ വെച്ചിട്ടാണ്. അപ്പോൾ ആഫ്റ്റർ MSc, if you have to have a leap forward, then you should clear net, either for assistant professorship or research and lectureship, or for lectureship or research only. So serious ആയിട്ട് എടുക്കുക. take this one as a serious. നിങ്ങൾക്ക് നിങ്ങളുടെ ഭാവിയെപ്പറ്റി ചിന്തയുണ്ടെങ്കിൽ തീർച്ചയായും നെറ്റിന് പഠിക്കുക, ആത്മാർത്ഥമായിട്ട് പഠിക്കുക. എത്രയും പെട്ടെന്ന് പഠിക്കാൻ തുടങ്ങുന്നെങ്കിൽ അത്രയും നല്ലത്. ക്ലിയർ? മനസ്സിലായെന്ന് കരുതുന്നു. So next one, next question. Consider a mass m connected to a massless springs as shown in the figure. I will be giving you the figure. The spring constant of a spring A is Ka and that of a B is Kb. The springs are shown in a relaxed position and the angle theta in this position is pi by 3. The mass is displaced horizontally by a small distance. What is the angular frequency of small oscillations of m? So this comes under the topic is small oscillations. So this is the figure. See, the figure is given like this. This is my wall and this is my horizontal axis, and a spring 1 is connected like this. The spring 2 is connected like this, and both springs meet here, and then they are connected to another spring and it is connected to a mass m, and it is connected to a mass m. So this is a spring A, this is a spring A, both springs are identical, and this angle is this angle is 30 degree. This angle is 30 degree, and this is B. So this is my figure. So see, read the question again. Consider a mass M connected to a network of massless springs as shown. The spring constant of spring A is Ka, and that of B is Kb. The springs are shown in the relaxed position, and the angle theta is pi by 3. The angle theta is pi by 3. So this is angle theta. Sorry, this is angle theta. This is 60 degree. So this is 60. So this is 90. So this will be 30. Obvious. Then the mass is displaced horizontally by a small distance. Displaced horizontally by a small distance and then released. So then it will execute small oscillations, and we have to find the angular frequency of small oscillations. So that is what the question is. So we know if you suppose the displacement of spring B is assumed as x. If you release the mass or if you extend the mass, the displacement in spring B is assumed as x. So the displacement of spring B x, it is x. So if it is x, then you can say that the displacement is x. So so you have to calculate the displacement of these two springs. Okay, so this will be expanded by x. If it is expanded by x, this distance will also be expanded by x. So this will be, if this is 30, if this is x, and this is 30, this will be x cos 30, isn't it? X cos 30. So therefore the displacement of spring A will be x cos 30, isn't it? So the displacement of the spring A will be x cos 30. So now let us find the resultant. See now. So what will be this angle is 30 degree. So this angle is 30 degree, and this is what then. So the displacement will be x cos 30. The displacement is x cos 30. It will be, the spring will be looking like this, isn't it? This is pulling over. So keeping this figure in mind, you can see the net force. The net force F is equal to force F is equal to kx, isn't it? Force constant into displacement. So the net force F is equal to what? The force constant will be Ka. The displacement is x cos 30. So the net force F is equal to Ka into x cos 30, isn't it? So then you can say that if it is Ka into x cos 30, so or then you can say that now we calculated the net force. So if it is if we calculated the net force, you can now see this is the direction of force. Now you can resolve this. One component will be in this direction, the other component will be in this direction. For this force, one component will be in this direction and the other component will be in this direction. This is 30, so this is F cos 30 plus F cos 30, isn't it? This will be F sin 30. This will be F sin 30. So since both are equal, they will be cancelling each other. And what will be the net force? This will be 2F. Net force will be 2F cos 30. 2F cos 30. And what is F? F is K into x cos 30, isn't it? So so therefore we can write it as therefore 2 into substitute for F. What will be F? F will be F will be Ka into x cos 30. So Ka into cos 30 into cos 30. Ka into cos 30 into cos 30. So what will be that? So so this will be 2 into Ka into cos 30. Cos 30 is root 3 by 2, isn't it? So it is root 3 by 2 into cos 30 is again root 3 by 2. So 2 and 2 cancels, and what will you get? It will be 3 by 2 Ka. So you will be getting 3 by 2 Ka, isn't it? So you got you got this as 3 by 2 Ka. What is this 3 by 2 Ka? The resultant of these two. The resultant of force constants of these two springs as 3 by 2 Ka. Okay. Now think the resultant of these two, or you may think of two resistances connected like this. Two resistances three resistances connected like this. You will find the resultant of these two, and then the resultant of these two will be added. The resultant of these two will be added like this. So we will say that these two are in series in such a way that we got the resultant of force constants of these two springs as 3 by 2 Ka. Now we can assume that one spring is like this, one spring is like this. The constant of this spring is Kb. The force constant of this spring is 3 by 2 Ka, and the mass is connected. Now it has become easy. Two springs are in series. When two springs are in series, the net force constant will be equal to K1 K2 divided by K1 plus K2. K1 K2 divided by K1 plus K2. So this is equal to what? K1. K1 is 3 by 2 Ka into Kb divided by 3 by 2 Ka plus Kb. So take the LCM. This will be 3 by 2 Ka Kb divided by 3 Ka plus 2 Kb by 2. So 2 and 2 cancels, and you will get a net Ka. K net is equal to K net is equal to what? K net is equal to 3 Ka Kb divided by 3 Ka Kb divided by 3 Ka plus 2 Kb plus 2 Kb. So you got the net K for this system. So if you get the net K, you can say that omega you can say that omega equals or K is equal to m omega square, isn't it? So K net is equal to m omega square, or omega equals under root K net by m. What is K net? K net is 3 Ka Kb divided by m into 3 Ka plus 2 Kb. 3 Ka plus 2 Kb. So this is the required angular frequency for this system. So the only thing is you should know how to calculate the resultant of the net force constants of these two springs added to the series combination of the other spring. So you will get K1 K2 divided by K1 plus K2. The series combination of springs will be like the parallel combination of resistances. So you will get the net, and then you will get the angular frequency. Understood? So is it clear? So I taught you how to calculate 3 by 2 Ka there, and then how to add these two and how to find. I hope this is understood. You should study this. Okay. So let us move into the next one. So consider a system of 3 electric charges. First one, a charge minus q placed at the point 0, d. Second, a charge alpha q placed at the origin, and a charge minus beta q placed at 0, minus d. The values of alpha and beta are such that the monopole, sir exam net re-exam hoga ya nahi? No, the re-exam has to be conducted in the coming weeks, 25, 26 and 27. July 25, 26, 27. Sir, please reply. Amit Sharma, the thing is I cannot understand Hindi that much. Re-exam has to be conducted. It is to be happen. So it is to happen on July 25, 26 and 27. Okay. So if there is there is no problem has happened, it will be conducted on 25, 26 and 27. If something happens like in the case of June exam, it will be postponed. Till now there is no news of being postponed. It will be conducted on this month itself. Okay. Amit, I hope it's clear. Please reply. UGC net re-exam, no. The UGC re-exam, it is scheduled to be in August. UGC. This is a CSIR. CSIR exam will be conducted in July, and this will be, yes, 21st August. Yes, correct. You are right. So third one, third charge minus beta q is placed at 0, 0 minus d, and the values of alpha and beta are such that, please read this carefully, the monopole and dipole terms vanish in the multipole expansion of the electrostatic potential. What is the quadrupole term of the potential at this point? See, you are given a system of charges, and in that system of charges they have given you the monopole term is 0. So obviously we will think that it will be the dipole term will be dominant, the dipole term will be present. So but they have also told that the dipole term is also 0. So since the dipole term is 0, then the quadrupole term will be the dominant term. It will be the leading term. So the quadrupole term will be, you have to calculate the quadrupole term at x, y, comma 0. Clear? So I will give you the figure. See, this is the figure. So they have given you a plane like this, and this is my figure, and see, this is like this. So this is my origin. So this will be my origin, and minus q is placed at here, isn't it? Placed here. Minus q is placed here. Then alpha q is placed at the origin, and beta q is placed at 0, 0 minus d. 0, 0 minus d. Beta q is placed at 0, 0 minus d. So obviously this will be my x axis, and this will be my y axis. Okay. So we have to calculate the quadrupole term. So now let us go through. So so they have given you the monopole term is 0. Monopole term is 0. So monopole term, what does monopole term means? Monopole term means the total charge is 0. So the total charge should be 0. So monopole term equal to 0 implies total charge. Total charge should be equal to 0. So what is the total charge? Minus q plus alpha q minus plus beta q, isn't it? Minus q plus alpha q plus minus beta q, isn't it? Minus beta q. So this will be minus beta q. Minus beta q should be equal to 0. Minus beta q should be equal to 0. So what does that mean? Minus q plus alpha q minus beta q should be equal to 0. So so what will you get? So if you compare the coefficients, you will get alpha minus beta should be equal to 0. So alpha minus beta. So if you take this q common, or minus q plus q into alpha minus beta equals 0, or q into alpha minus beta equals q and q cancels. So alpha minus beta equals 1 for those who don't know. So alpha minus beta equals 1. So you got alpha minus beta equals 1. Then this is the case of monopole term. Then go to the dipole term. So what is dipole term? Dipole term should be equal to 0. Dipole term is also 0. So since the dipole term is 0, the dipole moment should be equal to 0. The dipole moment should be equal to 0, isn't it? So what is the dipole moment? Dipole moment is charge into distance, charge into distance, plus charge into distance, plus charge into distance. See, there are 3 charges. So first one, here minus q is placed at a distance d from the origin. Then alpha q is placed at the origin, so there is no distance, minus beta q into which is placed at a distance minus d from origin. So this should be equal to 0. So this is equal to 0. So what will you get? Minus qd minus plus beta qd equals 0. So beta qd equals qd, and you will get beta equals 1. So you got beta equals 1. Okay, so beta equals 1. So substitute it here. So if beta equals 1, alpha equals 2. So beta equals 1 and alpha equals 2. So you got a value of beta and alpha. Clear? And now redraw the figure. So what will be that? This will be minus q at 0, 0, 0, 0 d. Then alpha q. What is alpha? It is 2q at the origin, and this will be what? Beta. What is beta? Beta is 1. So minus q. This is again minus q at 0, 0 minus d, and you have to calculate. What do you have to calculate? You have to calculate. You have to calculate the quadrupole term at a point x, y, 0. You have to calculate the quadrupole term at x, y, 0. That means in the x, y plane you have to calculate the quadrupole term. Okay. So if you calculate the x, y term, if you calculate the quadrupole term in the x, y plane, see, this is the x, y plane, suppose. So this is my point, some p. So x, y, 0, x, y, 0. So this is my point. So now I have to calculate the quadrupole term or the quadrupole potential at that point. Okay. So we have to calculate the potential. So the potential due to the charge. So shall I rub this so that I can write it more clearly? So I am writing it again. So these are my 3 charges. So what are those? Minus q, which is placed at 0, 0 d. This is a 2q placed at 0, 0, 0, and this is q which is minus q, which is placed at 0, 0 minus d, and this is my point p at the xy 0. So we know how to find the potential. The potential at a point. Potential at a point due to a charge can be calculated. V is equal to 1 by 4 pi epsilon 0 into q divided by r. What is that r? R is under root, if you are given 2 points, under root x2 minus x1, isn't it? x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. This is the position vector. Just the position vector only r, isn't it? So you know r square. R square is x2 minus x1 into I cap plus y2 minus y1 j cap plus z2 minus z1 j cap, k cap. So we have, since we require only r, we take like this. Clear? So v. So you got v. So the potential at the interested point p is equal to k into first one, k into what is the q? This is minus q. So minus kq divided by under root what is x2 minus x1? x2 minus x1. x2 is x, x1 is 0. So it is x square. Then y2 minus y1. y2 minus y1 is y minus 0. So it is plus y square. z2 minus z1 whole square. So it is minus d square. So that is d square plus d square plus next one. This is 2kq, isn't it? 2kq divided by root of x2, that is x square plus y square, isn't it? X square plus y square, then minus kq divided by same thing, x2 minus x1, isn't it? So this is x square plus y square plus d square, root of x square plus y square plus d square, isn't it? So minus kq divided by root of x square plus y square plus d square plus 2kq divided by root of x square plus y square minus kq divided by root of x square plus y square plus d square. Then add up. So Vp is equal to minus kq plus minus kq minus 2kq divided by root of x square plus y square plus d square plus 2kq divided by root of x square plus y square, root of x square plus y square. Understood? So now what will we do? We will take we can take, see, 2kq divided by root of x square plus y square could be taken common. So Vp is equal to 2kq divided by root of x square plus y square is taken common. So it will be 1 minus 1 by root of what will be there? So I have taken x square plus y square common. So 1 by root of 1 plus here it will be 1 plus d square divided by x square plus y square, isn't it? D square divided by x square plus y square, d square divided by x square plus y square, isn't it? So you got Vp 2kq divided by x square root of x square plus y square into 1 minus 1 by root of 1 plus d square divided by x square plus y square. So simplify this again. So see, I am writing it again here. See, so Vp is equal to 2kq divided by root of x square plus y square into 1 minus see what will be that, this will be 1 minus, see, I am taking this denominator to the numerator, so it will be 1 plus d square divided by x square plus y square all raised to minus 1 by 2, So this is equal to 2kq divided by root of x square plus y square into 1 minus, expand this, so this will be 1 minus 1 minus d square divided by 2 into x square plus y square, isn't it? Just a binomial expansion only. So 1 minus 1 cancels. So 2 and 2 cancels. So what will you get? So you will get Vp is equal to kq into d square divided by 2kq into d square divided by root into 1. So it will be x square plus y square raised to 3 by 2. So Vp is equal to kq d square divided by x square plus y square whole raised to 3 by 2, or if you substitute, if you are interested, you can substitute k, then it will be 1 by 4 pi epsilon 0 into q d square divided by x square plus y square whole raised to 3 by 2. Is it clear? So this is how we calculate the quadrupole potential at the particular point. Clear? So first you have given the monopole term is equal to 0 and dipole term is equal to 0. So using that both conditions, we calculated the coefficients alpha and beta, and then we used the alpha and beta to find the charges, and we found out the potential at a particular point, and then we simplified it and we got the potential, required quadrupole potential at this particular point. Is it clear? So I hope this is also understood. So you have to pay more attention to multipole expansions. It is very important in the exam point of view for electrodynamics, other than Maxwell's equations. Maxwell's equations are also important, and equally important is this multipole expansion. Clear? So I hope this is very clear to you, and now it's a high time to conclude my session. So one more question is remaining. We will hopefully we will solve it in the coming days. So നമ്മൾ അടുത്ത CSIR UGC നെറ്റ് ബാച്ചിലേക്കുള്ള നമ്മുടെ ഡിസംബർ ബാച്ചിലേക്കുള്ള നമ്മുടെ അഡ്മിഷൻസ് ആരംഭിച്ചിരിക്കുകയാണ്. അപ്പോൾ ജനറൽ പേപ്പർ, എക്കണോമിക്സ്, മാനേജ്മെൻറ്റ്, ഇംഗ്ലീഷ്, കൊമേഴ്സ്, CSIR, ഫിസിക്സ്, ഇത്രയും സബ്ജക്റ്റുകളാണ് കോമ്പറ്റേറ്റീവ് ക്രാക്കർ നിങ്ങൾക്ക് പ്രൊവൈഡ് ചെയ്യുന്നത്. അപ്പോൾ ഡിസംബർ നെറ്റ് നിങ്ങൾ സ്വപ്നം കാണുന്നവരാണോ എങ്കിൽ, വളരെ സിസ്റ്റമാറ്റിക് ആയിട്ട് നിങ്ങൾക്ക് പഠിക്കണമെന്ന് ആഗ്രഹമുണ്ടെങ്കിൽ, എക്സാമുകളൊക്കെ എഴുതി ലൈവ് ക്ലാസ്സുകളൊക്കെ അറ്റൻഡ് ചെയ്ത് ടീച്ചേഴ്സുമായിട്ട് ലൈവായിട്ട് ഇൻട്രാക്ട് ചെയ്ത് ഒരുമിച്ച് ഒരു സഹകരണ മനോഭാവത്തോടെ പഠിക്കാൻ ആണ് നിങ്ങളുടെ ഉദ്ദേശമെങ്കിൽ, ഇപ്പം ഞങ്ങളൊന്നും അവകാശപ്പെടുന്നില്ല, ഞാൻ അവകാശപ്പെടുന്നില്ല ഞാനെല്ലാം തികഞ്ഞ ആളാണെന്നോ എനിക്കെല്ലാം അറിയാവുന്നോ. ഞാൻ ക്ലാസ് എടുക്കുമ്പോൾ എനിക്ക് തെറ്റുപറ്റാറുണ്ട്, എൻ്റെ കുട്ടികൾ എന്നെ തിരുത്താറുണ്ട്, കുട്ടികൾക്ക് തെറ്റുപറ്റാറുണ്ട്, അവരെ ഞാൻ തിരുത്താറുണ്ട്. അങ്ങനെ ഒരു ഗിവ് ആൻഡ് ടേക്ക് പോളിസിയിൽ നമ്മൾ നമ്മുടെ ക്ലാസ്സുകൾ മുന്നോട്ട് കൊണ്ടുപോകുന്നു. അപ്പോൾ അവർക്ക് ഇഷ്ടപ്പെടുന്നുണ്ടെന്നാണ് എൻ്റെ ഒരു വിചാരം. അപ്പോൾ നിങ്ങൾക്ക് ഈ ഒരു സ്വപ്നം നിങ്ങളിലുണ്ടെങ്കിൽ തീർച്ചയായും ഡിസംബർ ബാച്ചിലേക്കുള്ള നമ്മുടെ ക്ലാസ്സുകളിൽ ജോയിൻ ചെയ്യുക. സമയം വേസ്റ്റ് ചെയ്യരുത്, ആലോചിച്ച് സമയം കളയാനില്ല. എത്രയും പെട്ടെന്ന് ജോയിൻ ചെയ്യുന്നോ അത്രയും കൂടുതൽ നിങ്ങൾക്ക് പഠിക്കാൻ സമയം കിട്ടും, നിങ്ങൾക്ക് അത്രയും റിലാക്സ് ചെയ്ത് ആസ്വദിച്ച് പഠിക്കാനുള്ള സമയവും കിട്ടും. സോ നിങ്ങൾക്ക് ഇത്തവണത്തെ CSIR ഫിസിക്സ് പരീക്ഷ എഴുതുന്ന എല്ലാവർക്കും ഒരിക്കൽ കൂടി എല്ലാ വിജയാശംസകളും നേരുന്നു. ആൻഡ് വിഷ് യു ഓൾ ദി ബെസ്റ്റ്. നിങ്ങളുടെ സ്വപ്നങ്ങൾ പൂവണിയട്ടെ. ഈ ഒരു എക്സാം നിങ്ങൾക്ക് ഒരു ടോട്ടൽ ലൈഫിൻ്റെ ഗതി നിർണ്ണയിക്കുന്ന ഒരു ലൈഫ് ചേഞ്ചിങ് മൊമെൻ്റായിട്ട് മാറട്ടെ എന്ന് എല്ലാവർക്കും ആശംസിച്ചുകൊണ്ട് എല്ലാവർക്കും എല്ലാ സഹകരണത്തിനും നന്ദി. ഗുഡ് ബൈ. താങ്ക് യു.